Welcome back. I'm now going to do a series of videos on the trigonometric identities. So let's just review what we already know about the trig function. So if we just write SOHCAHTOA, SOHCAHTOA, that tells us, and we've actually extended this with the unit circle definition, but if you watch those videos, you'll realize that the unit circle definition directly uses SOHCAHTOA. So we'll just stick with SOHCAHTOA because I think it'll help make some of what we're about to do seem a little bit more straightforward, and we'll kind of verge on the unit circle definition anyway. So we know that sine of theta is equal to opposite over hypotenuse, right? So cosine of theta is equal to adjacent over hypotenuse, and then the tangent of theta is equal to opposite over adjacent. So let's draw that out on a right triangle. We could do this with the unit circle as well, and it would make sense. And let's see if we could find a relationship between sine, cosine, and tangent. There's my right triangle. Let's call this theta. This is the hypotenuse h. This is the opposite side, right? Opposite of theta. This is theta right here. This is the adjacent side, right? Well, what do we know about the relationship between the opposite adjacent side and then the hypotenuse? What does the Pythagorean theorem tell us? Oh yeah, the opposite, this side squared plus this side squared is equal to the hypotenuse squared. So we could write that down. A squared plus O squared is equal to the hypotenuse squared, right? And then, this is just an equation. So if we want to, we could divide both sides of this equation by h squared, and so what do we get? We get a squared over h squared plus o squared over h squared is equal to 1, right? And then I could rewrite that as a over h squared plus o over h squared is equal to 1. Now, do these look at all familiar? Well, we have them here, right? This is a over h, and this is o over h. So we could just substitute. So this is just cosine of theta squared, and this is how you write cosine squared. You could put a parentheses around the whole thing and then square it, but this is just the notation people use. Plus opposite over adjacent squared, so that's sine theta squared equal to 1. So that's our first trig identity. So if you know the sine of theta, it's very easy to figure out the cosine of theta, right? You could just solve this equation, right? You could, if I know that let's say I know that the sine of theta, is, let's say 1/2, right? Then what is the cosine of theta? Cosine of theta is what? Well, I know the sine of theta is 1/2, right? So I would say cosine squared of theta plus sine of theta is 1/2, so 1/2 squared is equal to 1, right? So cosine squared theta plus 1/4 is equal to 1. And so we have cosine squared theta is equal to 3/4, or cosine of theta would be the square root of this, right? We just take the square root of both sides. So it would be the square root of 3 over 2. And you probably remember that from our whole presentation on the 30, 60, 90 triangle. So I just wanted to show you a use of this trig identity, that it's usually written sine squared plus cosine squared is equal to 1. So let's extend that one a little bit. Let's just play with the ratios and see what else we can, other, identities we can discover. Oh, whoops. Clear image, invert colors. So we know that the sine squared theta plus cosine squared theta is equal to 1. The one thing we could do is we could divide both sides of this equation by cosine squared of theta, and let's just see what happens when we do that. So if we say cosine squared theta, right, you have to distribute across both terms. Cosine squared of theta, and then cosine squared of theta. Well, what's sine squared theta over cosine squared theta? That's the same thing as sine of theta over cosine of theta, right? Squared plus, this is 1, is equal to 1 over cosine theta squared, right? I mean, 1 squared is 1, so I just rewrote it. So sine over cosine theta, I think we learned that already. That's just the tangent of theta. And in case you actually haven't learned that already, think about it this way. Sine is opposite over the hypotenuse, right? So that's opposite over hypotenuse. And then cosine is adjacent over hypotenuse. So adjacent over hypotenuse. So then that equals opposite over hypotenuse times hypotenuse over adjacent, right? Just dividing by a fraction is the same thing as multiplying by its reciprocal. That's all I did. And that equals opposite over adjacent, right? So that equals opposite over adjacent. So that just says sine of theta over cosine of theta is equal to tangent of theta. So sine squared theta over cosine squared theta is tan squared theta, and then plus 1 is 1 over cosine theta squared. And now I'm going to introduce a new trig ratio, and it's really just 1 over cosine theta. So 1 over cosine theta, and I'm going to summarize this at the end just so it's not too confusing, is actually the secant of theta. And it's just another ratio, right? And the secant of theta, instead of being the adjacent over the hypotenuse, would be the hypotenuse over the adjacent, right? It's just 1 over cosine theta. Nothing famous, nothing fancy here. So secant of theta. So that equals secant squared of theta. I know it can be a little overwhelming initially just because I'm, throwing out all of these new terms. Secant is 1 over cosine of theta. But once you just play around with these enough and get familiar with the terms, it'll make sense. It'll be a little more natural to you. So this could be, you could view this as another trig identity. And actually, in case, I don't even remember if I've taught it already. I mean, you could view this as a trig identity, although that's almost definitional. And then, of course, you can, in case I haven't done it already, you now know that sine of theta over cosine of theta is equal to tangent of theta. And that's, right here was, I guess you could say, the proof of it. So let me keep introducing you to more things, and if this is really daunting, maybe you just can rewatch it, and hopefully it'll make some sense. Let me see. Clear image, invert color. So what have we learned so far? We learned that sine squared theta plus cosine squared theta is equal to 1. We learned that sine of theta over cosine of theta is equal to tangent of theta. We learned that the tangent squared of theta plus 1 is equal to the secant of theta. And here let me actually write this definition down. The secant of theta, is equal to the secant squared of theta. Sorry. And the secant of theta is just 1 over cosine of theta. And this is something you really should just memorize. The secant is 1 over cosine. And if you're wondering what 1 over sine is, 1 over sine of theta, it's the cosecant, which the abbreviation is CSC of theta. And if you're wondering what 1 over the tangent is, it's the cotangent. And you just might want to memorize these. And this often confuses me, that 1 over the cosine is the secant, but 1 over the sine is the cosecant. So it's kind of almost the opposite, right? 1 over the sine has a co in it, while 1 over the cosine doesn't have the co in it. So that might help you remember things. So I think that's all I have time for now. In the next presentation, I'm going to introduce you to a couple of more trig identities. See you soon.